Hi friends, welcome back. Let us discuss about the Stefan Boltzmann law of radiation. So, this law gives the equation which is the governing equation for radiation. So, this law is stated by two scientists, namely Joseph Stefan and Ludwig, Ludwig, Ludwig Boltzmann. Hence, this is called as Stefan Boltzmann law of radiation. So, these two scientists made research on black body radiation and given this statement. So, before stating this statement, let us know some of the important terms related to or important points to be remembered related to radiation. So, first one, we all know that all bodies or substances are radiating energy. So, radiation of energy will be there for all the substances or all materials, but in the form of electromagnetic radiations. This is the first point. Second point is radiation you can describe also as heat flow from one place to another. It is also in the form of electromagnetic waves. So, this is the another definition for radiation. So, you can also describe radiation as heat flow from one place to another due to, that is, in the form of electromagnetic waves. Third point is, we should know every body, that means all bodies absorb and emit radiations. This is the fact we should know. All the bodies which absorb and emit radiations. Next point is to transfer heat between two bodies. No medium is required. We have seen some of the examples in previous slides also. No medium is required to transfer, that is heat between two bodies. Another point, that is, if heat transfer occurs through vacuum, then such type of heat transfer is called as thermal radiation. So, these are some of the points. Then we will go for the statement. So, As per Stefan Boltzmann law of radiation, it states that is total energy radiated, that is Q, per unit area of a surface of a black body per unit time is directly proportional to fourth power of absolute temperature or the black body's thermodynamic temperature, that is fourth power, T power 4. Here one term is there. What is this black body? So black body is one, that is it is a body or any substance which absorbs all the electromagnetic radiations, absorb all electromagnetic radiations incident on it at whatever that is regardless of frequency or angle of incidence, whatever the angle, okay, which is incident on the body, or at whatever the frequency, hertz, at whatever the frequency or angle of incidence, it is going to absorb all the electromagnetic radiations. This is nothing but the black body. What is white body? White body is one which reflects all in all direction. That means all radiations in all direction it is going to reflect. But here it is going to absorb all the radiations, whatever the frequency it may be or whatever the angle of incidence on it may be. Hence, so rate of heat transfer per unit area is directly proportional to fourth power of the black body's thermodynamic temperature or absolute temperature. That means Q is directly proportional to area, that is rate of heat transfer. It is also that is proportional to fourth power of temperature. Therefore, if you write this equal to or proportional to A and T power 4. So, Q per T, that is heat transfer rate, is equal to, here sigma is the proportionality constant, A T power 4, where Q is expressed in joule per second, that is T, rate of heat transfer. Then A is in terms of meter square and T is the black body's thermodynamic temperature expressed in Kelvin, that is power 4. Sigma is called as the Stefan Boltzmann constant. Stefan Boltzmann. It is given by its value, if you take it as 5.6704 into 10 to the power of minus 8. So if you take the unit of this sigma, that is, if you write equation for sigma is nothing but Q by T, rate of heat transfer, divided by area into temperature power 4. So it is joule per second divided by meter square K power 4. This is the unit, or even you can write watt per meter square Kelvin power 4. So this is the unit of Stefan Boltzmann constant. Hence watt per meter square Kelvin power 4. So rate of heat transfer is directly proportional to the fourth power of the black body's thermodynamic temperature or absolute temperature of the body. So equation you will get Q equal to sigma A T power 4. This is applicable for black body. If other than black body is there, what you will have to do? So if other than black body is there, then you have to consider emissivity of the body. Here emissivity of perfect black body is equal to 1. That means in this case E is equal to 1. If E is not 1, for other substances or bodies, E is greater than or equal to 0 and less than or equal to 1. So for all other bodies whose emissivity lies between 0 and 1, we can write the equation as Q is equal to, that is rate of heat transfer, is equal to emissivity, Stefan Boltzmann constant, area of the body and temperature power 4. So this is the equation for all other bodies other than black body. If black body is there, we can write the equation, that is Q equal to sigma A T power 4, where emissivity is 1. What is emissivity? Emissivity is nothing but energy that is radiated per unit area of the substance. So E energy, emissivity I will write here, energy radiated per unit area of a substance divided by same energy radiated per unit area of a black body. Here only difference is black body, but this is very important. Under same conditions. This is the definition of emissivity. Hence, so let us summarize. This law is called as the Stefan Boltzmann law of radiation. This law is for radiation. It states that rate of heat transfer per unit area is directly proportional to fourth power of the black body's thermodynamic temperature or absolute temperature. So this is given by Q equal to sigma A T power 4, where sigma is Stefan Boltzmann constant. It is taken as 5.6704 into 10 to the power of minus 8 watts per meter square Kelvin power 4. For the perfect black body, emissivity is taken as 1. For all other bodies other than black body, equation becomes Q equal to E sigma A T power 4, where emissivity lies between 0 and the 1. So emissivity is greater than or equal to 0 and less than or equal to 1 for all other substances or bodies. For black body, so emissivity is equal to 1. Other things to be known or other facts are, we know that radiation of energy are emitted by all the bodies in the form of electromagnetic radiations, and generally radiation is also described as heat flow from one place to another place, and we know that all bodies absorb and emit radiations, and to transfer the heat between two bodies no medium is required, and if heat transfer takes place through the vacuum, then it is called as thermal radiation. Thank you.